All right, let's just jump right in. Picture this. It's the 19th century. Science is absolutely exploding. New elements are being found all the time, but it is pure chaos. I mean, there's no system, no organization. It's just a messy, jumbled playlist of atoms. So today, we're going to unpack the story of the epic battle to tame that chaos and create the periodic table.
On our stage, we've got four main contenders who really stepped up. Johann Dobereiner, John Newlands, the absolute heavyweight Dmitri Mendeleev, and the young prodigy, Henry Moseley. So yeah, this is their story. A total scientific showdown for the ages.
Okay, so let's kick things off with round one. Our story starts way back in 1815 with our first contender, Johann Dobereiner. He was actually the first person to see a real tangible pattern start to emerge from that elemental mess.
So Dobereiner noticed something, actually something really elegant. He found these little groups of three elements and he called them triads. Now, here's the goal part. If you took the atomic weight of the first and third elements and averaged them, boom, you got the atomic weight of the middle one. Take lithium and potassium, average their weights, and you land right on sodium. It was the very first clue that there was a mathematical order to all this.
And you better believe Dobereiner was confident about it. He felt his discovery had, and I quote, main character energy. I mean, for the first time ever, it seemed like there was a predictable relationship between elements. It was a sign that this wasn't all just random. He knew he was onto something big. But here comes the first roast. John Newlands chimed in and pointed out a massive flaw in this idea. The problem was Dobereiner's super elegant pattern. It only worked for a tiny handful of elements. He could only find 3 real triads. For most of the other known elements, the math it didn't work. It was a great start, for sure, but way too limited.
And that leads us right into round two. Fast forward to 1864, and John Newlands enters the ring, and he brings a totally different vibe to the problem, a musical one. So Newlands proposed what he called the law of octaves. He lined up the elements by their increasing atomic weight, and he noticed this really amazing pattern. It's just like a musical scale, right? Where the 8th note is basically a higher version of the first one. Well, he saw that every 8th element seemed to share properties with the first one. For example, lithium had properties a lot like the 8th element after it, which was sodium. For Newlands, he'd done it. He made chemistry sing. His work was a huge leap forward because it introduced this idea of periodicity, this concept of a repeating, predictable pattern that seemed to govern everything. Suddenly, the chemical world had a rhythm. But then, the legend himself, Dmitri Mendeleev, steps up to the mic with a pretty harsh critique. He points out that Newlands' beautiful song went completely off key after the element calcium. For all the heavier elements, the pattern just fell apart. And what's worse, Newland's system didn't leave any room for new elements to be discovered. It was a closed box. And in Mendeleev's view, that was just delusional thinking. And that brings us to round 3. And honestly, to the main event, Dmitri Mendeleev. In 1869, he didn't just organize the elements. He built a system that could literally predict the future. So Mendeleev's big idea was his periodic law. He proposed that the properties of elements were all tied to their atomic weights. Now, he also arranged his table by increasing atomic weight, but he did it with a stroke of genius that just set him worlds apart from everyone else. And this is where you see his true genius. It wasn't just about organizing what he knew. It was about predicting what he didn't know. Mendeleev was so sure of his system that when an element didn't seem to fit, he didn't try to force it. No, he left a blank space, predicting that an element must exist to fill that spot. He even predicted an element he called ecosilicon and described its properties. And sure enough, years later, germanium was discovered, and it was a perfect match. This wasn't just organization. This was practically prophecy. Look, Mendeleev's table was a masterpiece for sure, but even a masterpiece can have a few glitches. And it took a young scientist with a totally fresh perspective, Henry Moseley, to find the bugs in the code. Moseley basically pointed out a couple of major skill issues. First up, these anomalous pairs. To make the properties line up, Mendeleev actually had to cheat his own rule and place some heavier elements before lighter ones, like cobalt before nickel. And second, what about isotopes? Elements like carbon-12 and carbon-14, which have different weights but the same chemical properties. Well, Mendeleev's table just had no place for them. So the big question is, how do you fix a legend's masterpiece? Well, that brings us to our final round.
Henry Moseley's ultimate fix, a brilliant discovery he made in 1912.
And this was the game changer, the fundamental shift. Using new X-ray technology, Moseley could look inside the atom, and he realized everyone had been focusing on the wrong thing. The true identity of an element, its real fingerprint, wasn't its total weight. It was its atomic number, the number of protons in its core. And this example just illustrates it perfectly. Remember that weird pair, cobalt and nickel? By weight, their order was all wrong, but by atomic number, well, cobalt is 27 and nickel is 28. They fall into place perfectly. No cheating required. Just like that, the glitch was solved. And this incredible revelation gave us the modern periodic law. It states that the properties of elements are periodic functions of their atomic numbers, not their weights. Moseley had found the fundamental truth, the one that provides the unshakable foundation for the periodic table we all use today. So, after this whole scientific journey, what's the big takeaway? What does this whole story really teach us? Let's bring it all home.
You know, the real beauty of this story is that every single step mattered. The so-called failures, they weren't failures at all. Dobereiner and Newlands, they found the rhythm. Mendeleev came along and built the essential structure. And then finally, Moseley uncovered the fundamental truth that locked it all into place. Science evolves. It builds on every single idea, good and bad, that came before it.
And we'll leave you with this final thought. This whole scientific journey actually holds a really powerful lesson for all of us. It's not just about the weight we carry or the mass we accumulate. It's about finding that core, fundamental thing that makes each of us unique, our own personal atomic number, and letting that define our place in the world. Find it and shine.